Good morning, everybody. First session of the day. How are we doing? Good. Yeah, we all had enough coffee. Sorry, that's such a first session thing to say. Anyway, wake up. All right, this is my favorite talk to give. Okay, I have a problem. I really like plants, and we're going to talk about that. But we're also going to talk about Kafka. So buckle up. This is going to be fun. Um, I want some interaction. I want to know that you're awake, please. Okay, we're all good? We're good? Okay, great. Thank you so much. So this is a Kafka talk, and there are traditions in the Kafka sphere. Bear with me. This is called a streaming selfie, and if I can see everybody, it will turn out okay. Okay, thank you for sitting tight. All right, some folks coming in. Grab a seat. All right, hello everybody. My name is Danica. I'm a developer advocate at Confluent, and basically my job is to get everybody excited about Kafka, right? So showing people how to adhere to best practices and also giving you an idea of cool things that you can actually build, okay? So in this talk, we're going to be talking about my houseplants, all right? Because I do have a problem. This is a small subset of the plants that I have. It was pretty embarrassing over the pandemic, right? Got a lot of houseplant. How many of you had a houseplant problem over the pandemic? Or at least bought one. Okay, it's considered a problem if you at least bought one, right? Yeah, I had plants before, but much to my partner's dismay, it kind of got out of hand in the middle of it. So this wasn't really a problem until we started going back to real life, though. Right? I'm leaving my house, okay? I'm not working from home 24/7. So I would come back home and find something like this, all right? This is a very dramatic plant, okay? He's okay. You come home and you see this. You're like, I've killed it. It's dead. I forgot to water it that day. Usually I have to do the rounds. I have like 40 or 50 plants. Yeah, it's it's a lot. I told you. I'm not crazy, I promise. But yeah, I have about 40 or 50 plants, and they don't all need to be watered at the same time, right? So I have to do rounds, like once or twice a day, check in on them, see if they're all right. But you start going into the office, right? And suddenly there are more important things. My boss wants me to do work, okay? So I forget about them, right? So I figure, all right, is there a better way for me to be doing this instead of running around my house checking on my plants at a couple times a day, right? Obviously, there's a better way, right? I'm an engineer. I've got skill sets, right? I can apply those to my problems, all right? And I know what you're thinking. If you have plants, maybe you've looked into this. There are totally pre-built solutions to help you monitor or even just water your plants, right? Well, that's silly. I don't want to use that. Okay, that's the wrong question. Is there a more interesting way? I'm an engineer, right? We don't want to just build this, have a solution. We want to build a more interesting solution, okay? And in this case, I've been using Kafka for a number of years. I'm in this job where I want to show people how to do cool things with Kafka, and I've always wanted an excuse to build out a hardware project. Okay, this was my chance. This is my time to shine, okay? So I figured I'd put together a practical streaming data pipeline, build it with Kafka, and hopefully get something out of it, right? All right, so let's talk design, okay? I needed something to monitor my plants, right? That's the most basic requirement that I had in this situation. And so I just wanted to do the monitoring. I know some of you are thinking, okay, but what about watering? I rent, okay? I can't set up a full irrigation system in my rental. I could. My landlords would not be happy though. So if we're gonna take it slow, I just wanna know when I need to water my plants, okay? That's gonna solve a lot of my problems. All right, I won't neglect them as much. So the system I envision was pretty simple. I'm gonna place soil moisture sensors in my plants, all right? Capture these, take these readings regularly using a Raspberry Pi, throw that into Kafka, and I'd enrich these readings with some metadata, right? I would need to know when these plants, like their comfortable moisture thresholds, right? When do they actually need to be watered? So I'd enrich those readings with that and use it to compute some outlier readings, right? But I need to get an alert at the end, right? Ideally on my phone, okay? That's always looking at our phones, okay? Yeah, I want it in the most convenient way possible. And so I've talked about Kafka a couple times already, I mentioned it. I want to make sure that we're all on the same page and we understand what Kafka is. How many of you have used Kafka? Okay. How many of you are using it in production? That's the real question. All right. How many of you have absolutely never heard of Kafka before and you're really excited about this? Okay, 2. What? Okay. Cool. You guys can leave. All right. Well, let's just talk about Kafka. I mean, you're all experts. So Kafka at the most basic level, this is the most refined definition I can come up with. It's almost academic. It's a distributed event streaming platform. It's such a short description, right? There is a lot to unpack here, so buckle up. We are doing that now, okay? So it is a streaming platform, all right? This shouldn't be a new phrase to any of you, right? Because we've been undergoing a paradigm shift in how we deal with our data, right? How we process our data. We're moving away from slower, more batch-oriented systems, and we're moving to real time, right? Where we want to capture and process information as close to when it was created as possible, right? So instead of waiting minutes, hours, days to group information and process over that batch, we're building more reactive systems, right? That are going to produce incremental results on smaller pieces of data in real time, ideally, okay? So this move to stream processing, there's a lot of benefits to it. You're going to increase the accuracy of your output data, usually. You're going to have, like I said, more reactive systems. That person who wants that report is going to get that information more quickly. And depending on how you actually implement a real-time system, you can actually increase the resiliency of your overall system, which is pretty cool. And Kafka is a platform that can help you achieve this, right? It's a streaming platform. Not only does it help to serve as sort of a messaging layer to move information quickly, it also serves as there's a persistent storage layer for you to keep data for a configurable amount of time. And then also, as we'll see, there's a processing layer involved where you can actually do your stream processing within the Kafka ecosystem. Right? It is an event platform, though. Okay. And if you take one thing away from this, those of you who are learning about Kafka for the first time now, is that in order to be successful with Kafka, you need to start thinking in events. All right, I know that might sound like a big ask. It's 8, 9, 10 in the morning. Okay, it's early, but I hope this sticks with you. I'm going to preface this by saying that as users, as humans, as programmers, you already think in and process in events, okay? So this shouldn't be that big of an ask, all right? I'm just asking you to be a little more conscious of this fact because you're interacting with forms online, right? You're submitting information. You look at application logs if you debug, hopefully. And then you react to notifications on your phone, on your computer, right? All of those things are events, all right? You already know how to interact with them, right? So those are examples of events, but what is an event really? It is a piece of information. That should be no surprise. Ideally, the smallest amount of information without too much excess, and this piece of information is going to describe something that has happened. Okay, that's pretty basic. We should be able to latch onto that. Okay, but we need to know when that thing happened, right? That's a crucial piece of information to include in that package, and we also need to know, any supporting details, who or what was involved, right? So tying it back to the plants, all right, and this system that I'm envisioning, right? So say that yesterday at 2:30 p.m., my umbrella plant pictured here had a soil moisture reading of 19%, right? So let's break that down. We have the timestamp yesterday at 2:30 p.m. We have the subject, the what, which is my umbrella plant, and the supporting detail, which is that it had a moisture reading of 19% at that moment, okay? A really critical piece of, key component of events is that they're meant to be immutable, okay? That may hurt some of you, but I need you to just accept that, all right? This is an unfortunate fact of life, right? Events are things that have happened. We don't have time machines, or I don't, at least, and so I can't really go back and change that event. That reading has been made. That plant had a moisture level of 19%. We are done at that moment, right? As much as I'd love to have a time machine, okay, I really don't. So how do I change this, right? How do I actually resolve this fact? I want to change that event. I cannot. My options are just to water the plant, right? So in watering the plant, I can raise its moisture level. Say we raise it to 70% today. And so I've kind of undone that fact, right? The initial one, that the plant had a 19% moisture level, right? Now, I've created a new event that today, if I took that moisture reading, it would be at 70%. And we've kind of, if you look at the overall, all of the events that describe this plant, the moisture readings, you can kind of build up a picture of, how neglectful I'm being about that particular plant, or how often I'm watering. You can get a full picture of the state of that plant over time by looking at these events, by looking at this timeline of moisture readings, right? And that's what we call a stream of events. All right, so Kafka is an event platform, all right? We want to be communicating these immutable facts throughout our system, right? And because they're immutable, there's a lot of cool things that happen in there. First of all, immutable pieces of information are really easy to move around, right, and append to data structures, because we're never going to touch them again. We're never going to try to alter them, right? So Kafka is a system that communicates in those immutable facts, meaning that we could be pretty efficient in how we move that information. And then later on, any sort of downstream systems or clients that want to tap into that information, we don't have to worry about the integrity of that data degrading over time, right? Because those facts have been written, they're not going to be changed, they're immutable, okay? There's a lot of benefits involved in that. I'll leave you to mull them over, we can talk about that later. But this is a really, really cool thing, okay? So Kafka can move information in real time, it's a streaming system, and we're communicating facts, okay? This is pretty powerful when you think about it. But to really understand that, we gotta think a little bit more about the architecture of Kafka. And it is a distributed system, for better or for worse. All right? So let's start with sort of the storage basics, how we actually interact with data in Kafka. So the primary unit of storage in Kafka is called a topic. And these topics represent a specific entity or a singular data set, usually, consisting of events. All right? So to get data into Kafka, we use separate clients called producers, and they write the events as key value pairs. We can have as many producers as we want, writing to as many Kafka topics as we want. There are no limits. Well, there are limits. Okay, there are totally limits on how many topics you should have in a Kafka cluster, but we don't have to get into that. All right, from there, to get data out of Kafka, we use another set of clients called consumers. And again, we can have as many consumers as we want, reading from as many Kafka topics as we want, within reason. Couple cool things about consumers. The first is that they keep track of a bookmark, right? As they're reading every event within the Kafka topic, if the consumer were to go down for some reason, we would want to know where we left off, right? So they maintain a bookmark called an offset, okay? That's a really important thing. Also with consumers, they are completely decoupled from the producers. They don't care about them. They don't need to know about them, right? The producers, their job is just to get the data into Kafka, and from there we could have as many consumers coming up and down over time, onboard new applications, pivot, be agile, all those fun buzzwords, right? They are completely decoupled, they don't care. All right, this is really good in the context of microservices architectures, so if you're interested in that, we can chat. All right, so consumers, another cool thing about them is they have the ability to work together in unison in something called a consumer group, okay? And in doing so, they have the ability to share the work of processing the events from an underlying topic or set of topics, okay? So we can parallelize the processing, right? But on the other hand, this is cool, they're flexible. Consumers also can just work completely independently. And so the same set of a set of maybe 10 consumers or so can each read from the same Kafka topics and all build up the exact same state from those events, okay? They're all going to read the exact same events from that underlying topic. And that's a really important thing when you start working with Kafka. For those of you who haven't worked with it yet, it's very easy to compare it to similar technologies. And the closest one is usually messaging queues, right? But in a Kafka topic, when the events are consumed, they do not go anywhere, okay? They are there for a configurable amount of time. Remember I said Kafka can serve as a persistent storage layer. So the data is there, immutably written, for anybody to tap into. So it's less of a messaging queue, and a Kafka topic is more like an application log, all right? Again, hopefully we've all done some debugging, maybe recently, maybe not too recently. So what happens when you read lines from a log? Okay, you're trying to find root cause. It's the only thing you have to do that day. You're reading line by line, trying to build up in your mind a state of that application. And by the way, every line in an application log file is an event. Okay, see? You are interacting with them all the time. Okay. All right, so you read line by line, you're building up the state of this application in your mind, and all right, maybe you can't figure it out, so you invite your colleague to come by and do the exact same thing. It's the same with the consumers, all right? You and your colleague are able to build up that same state based on these events in your mind, because as you consume them, they do not go anywhere, okay? So Kafka topics are the primary unit of storage, but they're actually broken down into slightly smaller components called partitions. Okay, you see sort of an example of them over here on the right. So here we have a Kafka topic broken up into 3 partitions. We've got 15 events spread throughout that. When you write data to a Kafka topic, it's a key value pair. We do a hash of that key if it exists, and based on our partitioning strategy, we will figure out what partition that particular event should go to. All right, so these partitions themselves are actually the immutable append-only logs where the events are actually stored across the Kafka cluster, okay? And we're breaking these up, we're splitting them to different areas of the system because Kafka is a distributed system. And this is going to provide better resilience and also facilitate replication, okay? And this is a really important thing in any distributed system. We want to make sure that we have highly available data, right? So let's take a look quickly at a Kafka cluster. So the nodes of a Kafka cluster are called brokers, and we can run them wherever we want. They can be on bare metal, VMs, containers, in the cloud. Doesn't matter, run them wherever, but just run many of them, right? So this is a simple cluster. We have 3 brokers, 3 nodes, 3 topics, and an assortment of partitions here. So the goal here is that we want our partitions per topic to be as evenly distributed as possible across the cluster, right? So that in the event that one of the brokers goes down, right? This seems like not a good thing, right? Right? A broker has gone down, we've lost some information, right? The good news is we've only lost 1/3 of our data, right? The bad news is we've lost 1/3 of our data. That seems problematic, right? So, but it's better than all of it being gone, right? But we're going to take it a step further with replication, right? So this is a configurable parameter that defines how many copies of a given partition should exist across the entire Kafka cluster. So here we're looking at, again, that 3-broker setup, but we're just going to look at one topic for now, all right? So we have our main partitions. Look at we have the leader partitions. Those are the ones that we are constantly interacting with. Our producers are producing to those lead partitions. Our consumers are, in most cases, consuming from those lead partitions. But then we also have backups. We have 2 additional follower replicas across the cluster, okay? And ideally, those replicas exist on a different broker than where the lead partition is, right? So broker 1, we have partition 0 as the lead replica, and we have our follower replicas existing on brokers 2 and 3. So in this case, what happens when a broker goes down? Well, really quickly, I just want to touch on this. The way that we actually conduct this replication, and this is pretty important, is that when the producer is writing to that topic, so say or that partition, when he's writing to partition 0, we are going to synchronously replicate that data over to the other brokers, okay? So that producer does not receive an acknowledgement, a success, that data has been written, until we have durably written it to all of the brokers where those replicas are, okay? So when a broker goes down, all right, this is still problematic. Immediately, we've lost partition 0, okay? So whatever producers were writing to that partition and whatever consumers were reading from that partition, they're directly impacted, right? We've lost some backups, but that's okay. We didn't need them anyway. That's fine. We've got some more. So what happens now? We want to be writing to partition 0 or reading from partition 0. Well, immediately, the cluster is going to realize, okay, after the consumer or the producer tries to interact with that partition, it's going to realize, okay, that one's down. We need to figure out what's our backup plan. So it's going to look for one of the follower replicas. It's going to find it, say on broker 2, broker 3. We're going to conduct a leader election process and figure out who to promote. And then it's going to go through that process and actually promote one of them to be the leader. So in this case, we're promoting partition 0 on broker 2, and the world will resume, right? Our producers and consumers can continue operating at that time. All right. So all of this to say that Kafka's pretty cool. All right, it has high availability built in. We're kind of avoiding some disaster scenarios. That's wonderful. It is a streaming platform. We're moving information quickly. We're communicating immutable events. It's pretty cool, pretty powerful. And this is just a teaser, all right? You should really check into it more if this is the first time you're hearing about it. All right, but let's get back to me, all right? This is more important. We want to build this plant platform. Okay, so going back to the design that we were talking, this little back of the napkin sort of diagram, okay? This is a very, very high level view of what I wanted to achieve, right? We have our Raspberry Pi grabbing these soil moisture readings. We're throwing it in the Kafka, combining it with metadata. On the bottom here, this is our symbol for ksqlDB for data processing, doing that within the Kafka ecosystem, and we're going to throw out an alert at some point, right? Looking at this, okay, there's not a lot of components, but there are some components here. This is my first hardware project. I mentioned that. It will not be my last. Okay, I'm very happy to say that. This was a lot of fun. All right, but it was my first hardware project, and going into it, I was nervous about how much work I was going to have to do to actually build this physical system. So much so that I really wanted to focus on the physical components, and what I didn't want to worry about was infrastructure. Right, managing any of the other infrastructure that I would need, specifically the Kafka side of it, right? So this is where Confluent comes in. So Confluent basically takes Apache Kafka and makes it simple, I think. So we have fully managed cloud-based Apache Kafka. So basically, for my Kafka side of things, I was able to just spin up a Kafka cluster in a couple of minutes and start producing, once I built the physical system, start producing events very quickly into that cluster. It's completely managed for me. I don't have to think about downtime. I don't have to think about setting up a lot of the configuration options to make sure that it continues running. And on top of that, there are some pretty cool tools built in. We'll get into a lot of these later, but we have tools for moving information into and out of Kafka with Kafka Connect, tools for stream processing built into the web UI with ksqlDB, and then also schema management just to make sure everything flows through as it should. But we'll get more into that later. Okay. So again, what am I trying to achieve with this project then? I first need to get my metadata, my plant details into Kafka, okay? That's the lowest bar possible. I just need to do that, right? From there, in between there, 0.5 is, actually building the system and being okay with it. Then capturing the soil moisture readings and using the Raspberry Pi and writing those into Kafka, right? And from there, we need to use some sort of stream processing to actually do the combining of those events, right? Joining those two, the metadata with the readings that we're producing. So I'd be using ksqlDB for this. And within this stage, I could determine if the readings that I were capturing, if they're within that allowable threshold that plant should have, right? And based on that, I can then trigger an alert. I can send out a message to let me know that I need to water that plant. And the way I'm going to do this is by using Kafka Connect to connect my Kafka cluster with my phone using Telegram. Ooh. Okay, the hardware. How many of you build out hardware projects? Okay, I hope the rest of you are inspired. Although it is kind of difficult now to get Raspberry Pis. It still is. Is it still difficult here? Okay, yeah. I got lucky, but this Raspberry Pi, for those of you who are familiar with hardware, this is overkill. This particular model for this situation. It was like the last one in stock I got before everything disappeared. So I have my Raspberry Pi. I also ended up using a breadboard. This was completely lucky on my part. I got it for free with my order. I didn't know I needed this, but I did need this. Okay, we'll get into this. I settled on these particular soil moisture sensors. I learned a lot about soil moisture sensors. Man, this is not like a new space for anybody. There are so many options out there, like, it was insane. Anyway, I settled on these ones. They had stemma connectors on them, so they're pretty much plug and play. Well, until I had to solder. But up until that point, it was plug and play. And I was using their I2C, their capacitive moisture sensors, meaning that they're not going to degrade over time as much as the other types. All right, so settled on these. A lot of cables. Again, first hardware project, so for some reason, I was like, I should solder everything myself. I should crimp all the wires, right? I wanted the full experience. I don't know if that was the right choice, but I learned a lot, okay? I learned a lot. All right, so it did. There was a there was a lot of like blood, sweat, and tears involved, and I had a soldering iron in my garage. My partner had one, and at one point I was like, wearing magnifying glasses, like trying to put these things together, and he's just like, "Well, don't lick your fingers." I'm like, "What do you mean?" "Oh, everything's lead based. Isn't that fun?" Anyway, it's a really great process. I enjoyed it. Anyway, so the software side of things. A little outdated here on the Python version, but 3.7 is what I have on my Raspberry Pi right now. Running Confluent Kafka 1.7. This is the Python module. And as I said, we're going to be leveraging our fully managed Confluent cluster so that I didn't have to think about it, right? So we're setting up the cluster in the cloud. I'm going to be leveraging the in-browser stream processing with ksqlDB. I'm going to be using fully managed Kafka Connect, meaning that to get my data out of Kafka at the end, I'm also not going to run Kafka Connect outside of that ecosystem. I'm not going to think about it. They're going to manage it for me. And I will be taking advantage of schema registry as well. Okay, we can actually start now. All right, that was just the intro. I was told I had an hour for this. I'm like, man, this is great. Usually I only have like 35 minutes, so we're really going to touch everything. All right, so when you embark on any sort of data-related project, that's a joke. Every project's data-related to some degree. When you embark on any sort of project, the first step, know your data, please. My first job was in data warehousing, building reports, and I would get so many requests on, can you do this, this, and this? No, did you look at your data? Do you know what data we have? It's not what you think we have, right? So, and that all could have been avoided if we just sat down in the beginning and really thought about what data we needed to achieve the things we want, right? So I wanted to avoid all of that, and I spent probably too much time thinking about the schemas for these data sets. But I did. I took a step back, had a cup of tea after burning myself with a soldering iron, and really thought about what information I wanted to use. So I ended up creating 2 Avro schemas. Remember, we're going to use schema registry to keep track of our data and our schemas. So the first was for the readings that we're actually capturing from the soil moisture sensors. So we're generating events, right? All right, so I need to be able to fully capture what that event is. What information do I need to describe what is happening at each reading, right? So, all right, I need a timestamp, right? There is no timestamp in here. Sorry. That is implicitly contained in the Kafka message, right? I can specify a timestamp. I could have added one in here if I wanted, but I'm just going to use the produce time. Whenever my producer writes this event, that is the timestamp I'm going to implicitly use with that event, okay? So that's in there, I promise. And you know what plant was involved, so we have the plant ID. We're also going to use that as the key of that key value pair that we write to Kafka. And then we're also capturing moisture level, right, which I translate into a percentage based on the ranges of the particular soil moisture sensors that I'm using. And also I get temperature for free. Still thinking about how I want to use that because honestly, like, yes, every plant does have a temperature threshold. My house is never outside of that. It would be very worrisome if my house were that cold or that warm. So, but that's in there. We'll get to that maybe. All right, V2. And then also we need to know, what information we need for the plants, right? At the very basic level, I need to know the moisture threshold that the plant was comfortable within, right? Pretty much all of houseplants are within, 20 to 60% moisture, soil moisture is okay. But like that first plant that I showed you in the beginning, that one's a little pickier, okay? So we need a slightly different range. So there was some guessing and checking and thinking about, even after the system was running, like actually understanding what threshold the plants are comfortable within. But I definitely needed that information. I did the same thing for the temperature thresholds. And then also some extra information to make it a little easier for me when I'm looking at the data within the console. So obviously I need my plant ID, right, so that I can join it onto the readings that we're generating. And we have the names of the plants. All of my plants have names, given names, okay? Really, it makes me feel connected to them, and then I feel like if I didn't name them, I would just completely neglect them, right? It's something different when, you get an alert on your phone that says, Bradley's sad, right? Right, rather than go water, go water that plant. All right, so we've got our scientific names, the common name, common plant name, and then also our given name, right? Okay. How many plants? I've got like 50 plants, and there are 50 names. There are no overlaps. Although every time I ask my niece is 6 years old now, and I like to include her when I get new plants. Like, what should I name this one? And she usually says either like John or Brenda. And I'm like, no, we've got those already. Like, you gotta think of a new one. So anyway, they have to be unique. They wouldn't feel loved otherwise. Come on. All right, so we know what data we want to be producing, right? We have a schema that we're going to adhere to. How do we get our data into Kafka? Great question. I would love to tell you. There are two main ways to do this. You can either use the producer API, using those clients that I talked about earlier, or we can use Kafka Connect, a source connector. Okay. I know I have verses in there, like they're pitted against each other, right? I'm just a confrontational person. I think this is fun, but it really isn't. It isn't a competition. All right. There are specific use cases where you'd want to use the producer API over Kafka Connect and vice versa. All right. So pay attention. Okay. So, producer API, this is your low-level vanilla option for getting information into Kafka, right? We're going to create producer clients, pretty much available in any language you would want at this point. There's so many options. So you just pick whatever you want. A colleague of mine likes to say you can choose Haskell or any lesser languages. So proceed at your own risk, all right? You'll want to be using the producer API when you either own or you have access to the system or the application that's actually generating the data, right? So for example, if you wanted to capture, log events from your application, right, you would just add a couple lines to add a producer at a particular point in time, and then produce those messages as those log events occur, right? There are other ways to do that, but if you wanted to use the producer API, that's a pretty easy way to do that, right? The other option is using Kafka Connect. All right, and as the name implies, Kafka Connect is a way to connect Kafka with other data sources and sinks. In this case, a source, right? It's pretty cool. I think it's pretty great because it's low or no code in many cases, because there are dozens of fully managed connectors that you can just run through Confluent Cloud, and hundreds of other connectors for written specifically for different data sources and sinks, right? So for any data source or sink, it's probably available, right? You don't have to write a new connector. You can just fill out a configuration and run it, right? Which is pretty convenient. And if you are unlucky and your data source or sink is not one of the pre-written ones, it only takes like 2,000 lines of code to write one. No, it's not that bad. It's actually pretty easy. All the classes are there available to you. It is JVM based, sorry. But it's pretty simple to write another Kafka connector if you'd like to. In my case, though, since I am using Confluent Cloud, like I said, there are dozens of fully managed ones. So effectively, Confluent Cloud is just going to walk you through a wizard for setting up your configuration. I don't even have to think about what configurations I need to make this connector work properly. It will import all of your topics so you know what topics you want to be working with and moving that data to or from. And it's pretty simple. So Connect is a really, really great thing to use when you're trying to integrate with data that's at rest. That's kind of the term we use. So if it's at the, in a database, right, is the standard one, right? We have information in a database. We want to translate those updates, those inserts into events and combine them with other events in Kafka. So we're going to use Kafka Connect. But you can also, there's an HTTP source connector, so at the other end of an API call, you can capture that information at regular intervals and produce that as events. So a lot of options. It's a really cool tool. It makes life so much easier. So what did I use in my case? Only the producer API. Yeah, I know the metadata is kind of something that would be at rest, right? That's something I should have put in a database. But again, I didn't want to manage anything. I didn't want to think about that. So I was just going to, from the beginning, I decided I would use the producer API and manually produce all of that information into Kafka. So and at the beginning, I only had 4 plants to monitor. This is very underwhelming. I know you were expecting a system for all 50 plants. That's a lot of wire, okay? It's going to get expensive. Also, these particular soil moisture sensors that I got, this wasn't like written in bold print. I bought a bunch of them, but you can only physically change, so they communicate over I²C, so they need to have a unique address in order for the Raspberry Pi to be able to pull the information from that sensor, okay? And on these ones, okay, you can change the address, but to one of 4 values. So I could only use 4 sensors. There are ways to get around this, I know, but I had put away the soldering iron, I was done, I didn't want to think about it. So yes, for version 1 of this system, we only had 4 sensors. So I only had 4 rows of plant metadata to actually put into Kafka. So it's like, I don't need a database for that. We're just going to store that in a text file, right, and put that in there. Anyway, so, but I did write a producer script to actually, take that information and serialize it, adhering to that schema that I wrote, right? We want to stick with our schemas, and write that into Kafka. I also, for the houseplant readings, I wrote a script that's just going to capture those readings. Initially, I did it at like 5-second intervals. Right now, I switched to 2 30-second intervals. I don't need the information that quickly, but I still want to have a lot of information for any analysis that I do. But within that script, I created a static mapping of plant ID to the sensor ID, right? Because I want to know what plant I'm capturing soil moisture information for, right? So I have that, and I'm just looping over it and capturing those sensor readings. Okay, the data is in Kafka. Okay, we have our metadata in, I manually produce that. I am capturing readings at regular intervals. Now I need to actually process the information, okay? There are a couple different ways to do this processing. We're gonna start from the most complicated and get to the easiest, all right? So bear with me. The OG way is to use that producer and consumer API that I discussed, okay? They're really great, like I said. You can use them in whatever language you want, so you're free to, to run in whatever system you want, use whatever you want. But to use them for stream processing, right, you have to set up a consumer to regularly pull that information from Kafka, consume that, do whatever processing that you want to do. If it's stateless, great, you're lucky. If it's stateful, you have to manage that state, right? Because if that application goes down, you don't want to like reprocess. I don't know, in this case, maybe it doesn't matter, but for real use cases, right, that's, maybe you don't want to reprocess that data. You don't want to have duplicates involved, right? So you have to manage all of that state, handle sort of failover situations in the event that one of those applications goes down. How do you recover? And then you also have to, at the end, produce that information back into Kafka. So there's a lot of managing of these clients. Can you do it? Absolutely. I mean, people were doing that for a while. That's totally fine. You can do it. But there are easier ways to do it. Why would we do it the more complicated? It's not even the more interesting way, right? I would give you a concession if that was the more interesting way to do it. But honestly, I think Kafka Streams is way cooler. So if you're a sane person, you're probably going to use Kafka Streams, or you're going to look at that first, right? Kafka Streams is a Java and Scala library specifically written for stream processing. Okay, so it really, the major benefit is that it takes that hassle of managing state off your hands. Okay, so you can spin up multiple Kafka Streams applications on completely different machines. They're all going to coordinate. Those consumers are going to be part of a consumer group. They're going to share the work of processing all the information from that input topic. Whatever state you're dealing with is going to be backed also by a changelog topic in Kafka, so that in the event that one of those applications goes down, it can, first of all, rebalance whatever work that particular instance was processing. It will be rebalanced and distributed to the other running instances. And then also we're going to have that transfer of state in there so that you can keep more or less seamlessly operating. So really awesome library. Some of the options you have for stateful processing are there on the right. Filtering, we can do the mapping, joining, aggregating, windowing. It's all in there, and it's way, way nicer than just using the consumer producer API. So that might sound like a lot of work, though. It is a JVM application, so if that's not interesting to you, we have ksqlDB. This is what I ended up using. So ksqlDB is actually built on top of Kafka Streams, and it allows you to build stream processing applications using SQL, right, within the browser. So great, okay? So you have access to that powerful stream processing, but you don't have to think about, writing. Kafka Streams applications can get pretty lengthy depending on what you're trying to do. But you can be using ksqlDB to just write a couple SQL statements and do some pretty complicated, not only stateless processing, but very stateful processing. There are a lot of customers that I know of using this for like real-time fraud detection, and so there's a lot of cool things that you can do in just a couple lines of SQL. All right, so you see on the right over here, we have just our standard. It's going to feel very familiar, very SQL-like, the joining, the windowing, grouping, and our standard sort of aggregating functions. Right. So this is what I chose to use, because again, I don't want to run anything on my own machines. We're just going to be using Confluent Cloud. So there are two main constructs when you're dealing with ksqlDB. So in vanilla SQL, you're creating tables, right? In ksql, you have an option. You're either going to create a stream or a table. Okay. Streams represent unbounded ongoing events. Okay, so tuck that away, think about that. Our tables are pretty much just the standard SQL table that you're familiar with, right? They're going to show the current state for a given key, okay? I'm going to end up using both of these for the readings and the metadata respectively, okay? So our data is in Kafka. They're in the Kafka topics where we would expect them to be. They have a schema. So let's bring it into ksqlDB. So the first thing you do is just create a ksqlDB application in Confluent Cloud. Just click some buttons, give it a name, it's fine. But there's no data in that application to begin with, right? So we need to basically configure our sources. What information are we pulling into this stream processing application? So the first thing I want to do is bring in that metadata. And the metadata, like I said, that's something that would probably exist in a database anyway, right? Because every time you update it for a given plant, if I update plant ID 0 with new moisture thresholds, I don't want to use the old representation, right? I want to know the latest value for that. So the table is pretty much just always grouping by that key and giving you the latest value for that, okay? All right, so to set this up, pretty simple. So the create table syntax should seem pretty familiar. But the with construct is interesting. This is where we actually connect it with the topics. So we point to the underlying topic that we want to be grabbing this information from. And then we have our value format, just saying, how is our the value of this table actually formatted? By specifying Avro, because that's what it is. We have our schema stored in the schema registry. This is really cool. So there were a lot of fields in those particular events, right? But I've only had to list ID here. So what's cool is that when you use Avro, when you have a schema, ksqlDB as a consumer can tap into the schema registry, access that schema, and then use that to parse the fields and their names. So I don't have to type those out. I don't have to worry about misspelling things, because I misspell things all the time. All I have to do in this case is specify what field should serve as the key, because in a table we do need to know a key. Okay, so I just have to explicitly call that out. And from here, ksqlDB will read those events and group by and choose the latest value for each key. Okay. So to run it, this is the Confluent Cloud ksqlDB console. Pretty simple. It's just an editor. You can run this in here, kind of guess and check. See, it has nice error checking in there. See what syntax works, and you just run this, and it will start creating those tables or streams behind the scenes. Okay. So creating the stream, all right, so we have our readings. I want to bring that into Kafka as well. Similar construct, except that we're, using a stream instead of a table. Oops. Again, you'll notice we're pointing to that Kafka topic. We specify the value format, Avro, so again, it's going to capture all of those fields and types for us. I don't have to think about it. I am just specifying to keep it in line with the table and naming that key with the ID so that we can do the joining later. So I will take this, I run it through the editor, and then that's going to be available as input to that streaming application. Okay. So we have those two sources available. We have our metadata, we have our readings available within that stream processing application, and now we need to start combining them, right? Enriching the one with the other, okay? So this is going to help me with the actual heavy lifting I want to be doing later. Okay, so first thing, let's look at the SQL. This is going to feel very familiar. This is a select statement for a regular join, right? So I'm selecting all the fields that I want as output from the main readings topic, and we're going to conduct an inner join with the metadata just to make sure that I always have all of the information I need at the end. I want to make sure I have metadata for whatever readings I get in. And we're joining on those readings, those ID fields. All right. We're creating a stream from this, okay? Because I don't want a table, right? I want all of the values. Every time we conduct this join, I want that value to be output. I want that row, that event, to be present in the output, okay? And since this represents, since our input topic, the readings, is an unbounded ongoing series of events, the output should be as well. So I'm specifying here just the topic I want to populate with that data. We're going to use that Avro format again. And then one other thing to notice, you may have missed it all the way at the bottom here, emit changes, okay? So that select statement here, I could just execute that on its own in ksql. It's not going to output, it's not going to be a persisted query that will output all of the information as new events come in on the readings topic. It'll just give me, what's already there. But by adding emit changes, I say every time a new event, a new change is detected on these input topics, I want you to output that result, okay? And we are going to append it to that stream that we just defined, okay? This is contrasted with a pull query, like I said, when we remove that emit changes, so I can just execute this. And this is just going to give me the current state of the application. What do I currently have in these topics? We're not going to persist this query, just give me the output. So in this case, I'm just selecting, I want to know the plants whose low moisture threshold is greater than 20%. And it's just going to output these 3 plants, their names, and it's done. The query's over, right? It's not persisted. It's not going to wait for more changes. It is done. Okay. So I've enriched the data. Oh no, I'm running behind. I enriched the data. So now we need to actually do the analysis. How do I get that alert at the end, right? So really quick, let's talk about what I want to achieve here, right? Whenever a plant has low moisture readings, right, indicating that it needs to be watered, I want an alert on my phone, right? How do I determine when to send an alert, and how often should I be sending these, right? If I alert on every reading that's coming through the system, I'm going to get a lot of alerts when the plant needs to be watered, right? So let's reduce that. So I figured if I'm out of the house or whatever, I'm in Norway, receiving an alert every 6 hours or so is probably good enough, right? And I've changed this over time depending on where I'm going and what I need to be doing, but that's good enough. Like that gives me time to either get home, not in this case, or tell my partner to water the plant, right? Also, these sensors aren't perfect. I noticed that I would get false low or false high readings within a set of time. But the general trend over time is that the plant needs to be watered, right? The moisture goes down. So I figured that over a 6-hour period, I'm getting, I think, 720 readings for each plant. It's probably good enough if I receive like an hour's worth of low readings. That probably means the plant needs to be watered, right? It's pretty good. So this is what I wrote to achieve this, all right? A lot to unpack here. First thing, okay, so how do I get it over 6 hours, right? Tumbling window, this is great. Non-overlapping tumbling windows, 1 line, you can specify this. So as this information comes in, and it's first going to be grouped in a window and assessed as part of that window, okay? 6 hours, grace period of 10 minutes, we're just gonna wait 10 minutes at the end of it to see if any new events come in for that window. Pretty easy. And from here, we're saying that, okay, first of all, we're gonna filter for the low moisture events, right? Whenever the moisture from that incoming reading is lower than that low moisture threshold, this is an event that I want to filter for and consider, okay? And you can see that as part of the select statement that we are counting those low readings, right? Anytime an incoming event meets this filter, we are going to count it, right? But we only want to output an event if it's more than an hour's worth of low readings, right? Oops, okay. Another couple things, and This might be kind of a tough thing to understand. I mean, it took me a while to really grasp what's going on in this and understanding. So this is a stateful operation, right? There is an underlying state associated with each plant per window in this query, okay? So as events come in, we're first assessing which window is it part of, right? Which state does this information belong to? We look at that plant ID, we look at the timestamp, and we put it as part of that. But within that window, for that plant, there's an underlying state represented by this low readings count, okay? So as events come in, we're incrementing that counter. And emit final, we have that at the end here where we saw emit changes before. Emit final specifies that we're not going to output changes, like emit changes, right? We don't want to output every event that comes through, but we're going to wait for the window to close before we output an event and assess whether or not we should output an event. So we're going to wait for my 6-hour window to close, give it an additional 10 minutes just in case things come in. And if that low reading count is above 120, we're going to output an event at the end of this, okay? That's exactly what I wanted to achieve. How cool is that? Okay, so I have those alerts in Kafka now. It's being saved in that houseplant low readings topic, right? So now I need to get it out of Kafka, right? This is a job for Kafka Connect, okay? I don't have to reinvent the wheel. I don't have to think about it. I set up an HTTP sync connector. So I said I wanted to get this information on my phone through Telegram. Telegram has a really, really convenient chat API, so I was able to set up a bot for my project. And its sole purpose is to let me know when a plant needs to be watered, right? So I get an alert on my phone. I use whatever the key, the token that Telegram gives me for that bot. And I have an endpoint that I can send information to for my specific conversation with that bot. And so I hook that up with the Kafka connector. And every time a new event comes in on that low readings field, low readings topic, the connector is going to pick that up and send it to my phone. Okay. Pretty convenient. And so this is what I get on my phone now. Bradley needs to be watered. So it's pretty great. It guilts me. But yeah, it's great. All right, so this is what we achieved, right? We are capturing our readings, we're combining it with metadata, doing some stream processing, I get an information on my phone. This is wonderful, but I can do better, okay? So right now, I'm monitoring 4 plants. But okay, what if I figure, those plants are fine. I know I have a regular schedule on when they need to be watered. I understand what they need. I want to switch some plants out. Or maybe I want to update the metadata. I don't want to go run that script every time I want to update plant information, right? So I figure, okay, I'm already using Telegram. Okay, I already have my conversation with my bot. What if I could produce data to Kafka from Telegram and have my own little personalized interactive application to move my plant sensors around, right, and update my plant metadata as well. So, right? Yeah, we're going back to this question. Is there a better way, right? I don't want to run that script every time. And I think this is more interesting. I've got my customized app now to interact with my plants. Okay. So this is the more practical setup that I want to use, right? We're still capturing those readings from the Raspberry Pi, but also I want to be generating that plant metadata from my phone using Telegram, throwing that into Kafka. But my Raspberry Pi also needs to be aware of that information, right? Because as I'm moving sensors around, I need to be able to update that mapping within that script that's generating the readings. So we're going to use Telegram as a producer, right? I said it has that very convenient chat API. There's a Python Telegram bot module library that is a wrapper for the API. So using that, you can define full conversation handlers to say, okay, you've responded to this thing, now respond to this and give me this information. You can request every piece of information for your particular use case. And so I have these 2 options available to update either the plant metadata, maybe the low moisture threshold is actually different for that plant, or I want to add a new set of metadata for a new plant. So I can do that through here. But then also, I need to be able to update the mappings. If I'm moving sensors around, I need to be able to say that this sensor ID is mapped to this plant. Okay. So I have this option now. And I need a new schema. All right, so in this case, I need to be able to communicate the sensor plant ID mapping. So I just have a new schema, a new topic to store this information in, where I have that sensor mapped to that particular plant. And so this is the general loop that I altered the script that's running on the Raspberry Pi. So we are consuming from that sensor plant mapping topic. And this topic is compact, meaning that every time that we add a new or we update a key, we're only going to keep the latest value over time. So in that loop, rather than just capturing the readings from the soil moisture sensors, we are first going to see if there's new changes on those plant sensor mappings, right? So it's going to do that, and so that consumer is going to do that and then pass those plant addresses into the producer. Something about the consumer is that I use these particular configurations with it. This is getting into some nitty-gritty details here. Basically, every time I restart this application, I want my consumer to start from 0, to start from the earliest event in the topic. So I'm not going to save its bookmark. I'm not going to let it commit any offsets, okay? So I tell it to start from the beginning using auto offset reset, meaning that if we don't have a bookmark, start from 0. And then I'm also saying enable auto commit. We're turning that off, so it's not going to commit a bookmark. Okay. And then from this, I was able to define my conversation handlers. So I can, in this case, we're updating the sensor mappings. It will ask me for which sensor ID I want to actually update here. I can specify the plant ID, and it will tell me whether or not it has been committed to Kafka. Still refining this to be more user-friendly, but I am the only user, so good enough. All right? And the same thing for the plant data. This is the most useful part for me, just updating the plant ID. There are some defaults in there as well, so if I don't want to deal with the temperature, I can just skip that, and again, follow the same process of committing that to Kafka. Right? So I'm happy. If we're looking at the user stories for this, I'm very pleased. I got exactly what I wanted out of this application, right? And I hope, okay, I know this is my thing. And I hope that you're inspired if you haven't done a hardware-related project or you haven't done one with Kafka. Maybe you will think about that, right? But the cooler thing is that I know we had fun here, but I tricked you, okay? Everything that I did, all the tools that I showed you, are all components that you're going to use in every streaming data pipeline that you're going to build using Kafka, right? Knowing how to use Kafka Connect to capture information from data at rest and move it into Kafka, using the producer API to capture information in real time and move it into Kafka, using stream processing with ksqlDB and moving it out of Kafka at the end, either with Connect or building some consumers. These are all of the components you need to build any streaming data pipeline. There might be some extra things in there depending on your use case, but you now are at least familiar with all the tools that you need to get started, and I hope that you will, right? So if you do end up building something interesting, or if you'd like to get started, I have resources on the right there. Oh my God, I don't know. Initially there's resources from Confluent Developer, how to get started with Kafka, with Confluent, with the cloud-based platform. And then also, if you're interested in seeing more of the, how I actually built my particular system, I don't know, maybe there's something else you want to monitor in your house. All of that's available there, and I encourage you to take a look. So, and with that, any questions? Yes.
You said you only have 4 moisture, what do you call them, sensors?
Yes.
But you have 50 plants?
Yes.
So how would that look like if you had scaled up with regards to how many Raspberry Pis and wiring?
Great question. That would be a lot. He's asking how that would scale if I was trying to actually use this for all of my plants. It would not scale well. There's a lot of coupling in there, with physical wires, and I would trip over all of them. But so the Raspberry Pis, it is just not economic for me to buy that many Raspberry Pis to set this up. If Pi Zeros were available right now, which they are just not for me, and they're also like $80 in the US, Yes, if those are cheaper. I am looking into alternative setups, not with a Raspberry Pi, but there are smaller boards that you can get that just operate off of a small battery that I could connect the sensors to. So I could potentially have a couple of those, hooked up to 2 or 3 sensors and capturing information in different clusters around the house. I am in the process of moving. I haven't gotten to that yet, but I am actually looking into getting those boards and setting it up that way instead, so that I can at least kind of localize and reduce the amount of wires that I do need. Yeah, because right now it does not scale. It does not scale. It could scale. Kafka could handle it, but it does not scale.
Or there is another option to have only one sensor and a robot which
Yeah, catch my talk next year. It'll be about this robot. Yeah, that's true. Well, so to get around that, that's kind of why I built the second part of this, where I have the interactive app, so that I can move the sensor around with a little easier, right? So I don't have to think about it. It's not just limited to those same 4 plants. Any other questions? Yes.
do you have a free tier?
Yes. Well, yes. Free to a degree, yeah. So when you're getting started with cloud, you get free credits that are enough to use. I think you have to, within 2 months or so. It's good enough to get started on one of these things. But yes, there are always promo codes that we have coming out that you can use to your heart's desire. Anyone else? I think I saw some questions up front. Yep.
Have you learned anything about your plants, like compared to just having and getting notification to water them, just not based on sensors?
Have I learned anything about the plants? That they're really dramatic. They're so needy. Like, you don't realize how often you're taking care of them until like I have an alert and I can look through the history and I'm like, man, like, am I awful? But it is really nice that for the plants that I do have hooked up to this, I fully rely on this application now. So it's like, if it fails, they might die. Like, I don't water until I get an alert, which is pretty cool. But I am learning more about like the fine tuning of the metadata, like understanding, and now like I'm definitely better at just like looking at the soil, and I'm like, okay, well I know that this isn't like below 20% moisture level now because I haven't gotten an alert. So it's cool that, yeah, I'm learning a little bit more. Yeah. Anyone else? Yes.
Why decided to use Kafka instead some special time series database like InfluxDB?
Yes. Well, I work for Confluent. That's the first. And I have all of these tools at my disposal. But also, it was just easier so I can tap into this information a little more easily when I want to build more applications off of it. Over the summer, I had an intern that wanted to do a little bit more analysis on the plants, combine it with other data sets, and so I was able to just give him access to that particular topic, and he could just start doing stream processing. So I wasn't looking at Kafka as like the end goal of where to put this information, but it's really just that middle layer so that other clients, other applications can tap into it when they need to. But I did look into, there's other arguments for maybe using like MQTT, very common in IoT, which really I can point you to some resources that, talking about how MQTT goes really well with Kafka. So, even if I had gone that route, I probably still would have had the information in Kafka eventually, just to have that persisted information and allow other people to tap into it. Good question. Anyone else? Yes? Oh my God. List all of the plant names. Absolutely not. So at the beginning of the pandemic, though, my neighbor, I was living in a small apartment, and my neighbors probably hated me because my craft, my hobby to keep me busy while I had all those plants was to create name tags for them. So I got a bunch of little copper tags and a tiny set of letters, like pins with letters at the end, so I could hammer them into it. That took me about a week. That kept me busy. I was like, man, this is going to take months. It's great. And like 5 days later, I was done. And my neighbors were like, are you leaving anytime soon? Can you leave? But that was very helpful in sort of keeping track of the names so I don't just forget who's who. And knowing the scientific names. That's the thing that I really wanted to know, is like be able to look at a plant and know what it's called, which is kind of fun. Got to store that information somewhere. Anyone else? Okay. Well, with that, I mean, you can find me later. I'll be walking around. I hope you enjoyed this, and I hope you're inspired. If you do end up building something, definitely reach out to me, either on LinkedIn, on Twitter. I'd like to see what you make. All right. Thank you.